You are welcome back to a session with me, your own friend, Edu Ada. Quickly today we'll talk about theoretical probability. Yes, we'll be on theoretical probability. And under this, we consider the following examples. First and foremost, I expect, let me say the definition or the meaning of probability. Probability is the number of outcome, and not just outcome, it is the number of required outcome over a number of possible outcome. Can you say that is correct? So flip it. The flipping will be correct thing. Number of possible outcome over the number of required outcome. What do I mean by that? Is what I mean. If you are seeing examples of probability such that balls in a basket, number of shirts worn, color by color contrast, different examples. But what you should take note of, the probability is something it is equal to the number of possible outcome upon the number of required outcome. Look at it. Probability of A should be equal to the number of possible outcome upon number of required outcome. That is, I want to ask you now, there are 20 students in a class, of which we have 5 girls. What is the probability of obtaining a girl? The number of obtaining a girl in that class will be number of girls as the number of possible number of girls you can get is 5. Then the required number of students, so that will be equal to 5 upon 20, and that will be 1 over 4. And also note that your probability of anything, probability of AF as a case study, probability of A will be less or equal to 1. Less or equal to 1. It cannot be greater than 0. So I can equally say is 0 is less. I can equally say 0 is less or equal to probability of A, where probability of A itself is less or equal to 1. So there is a boundary, and that is from 0 to 1, not less, not more than. So that's the range with which you should have the value of your probability. Quickly, let's go to our examples. We have example 1. It says two numbers are chosen at random from 1, 2, 3, 4. Find the probability that the sum of the two is not even. So here, all we need to do is we need a table to help us out. Okay, let me have this. 1, 2, 4. So the addition here. 1, 2, 4. To add these numbers, what do we have? This part. We'll wipe this so that I can get something contrasting. So when you add this, you see what the probability of getting something not even. It's not what find the probability that the sum of the two is not even. So let's go back to our work. 1 plus 1, 2, 1 plus 2, 3, 1 plus 3, and 1 plus 4, 5. 2 plus 1, 3. 2 plus 2, 4. 2 plus 4, 6. 4 plus 1, 5. 4 plus 2, 6. 4 plus 4, 8. It said find the probability that the sum of the two numbers is not even. If it is not even, then it will be what? It will be odd. It will be odd. The probability that is not even, I have this, it's not even, this is not even, it's not even, this is not even. So in the whole space, this is what? A space. How many values do we have? How many outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9. And out of that, so probability of no red. Sorry. Let me use NR. That will be equal to what? 1, 2, 3, 4. I have 4 upon 9. And you can't break that down, so we still have it as 4 upon 9. That's the probability. Question 2. Question 2 says that a die and a coin are tossed up together once. What's the probability of a tail and a 2 showing? The same thing, we are showing that theoretical probability. So here we also have for a coin, a die and a coin. Okay, a die is 1. Let me draw the table. 1, 2, 3, 4, 5, 6. A die is only head. The two outcomes of a die, of a coin rather, is just a head and a tail. So we have this, 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 we have this. What do we have here? We have H1. And go back, we have H2, H3, H4, H5, H6, T1, T2, T3, T4, T5, T6. You see that? Then here we're going to be having, to write that H1 so that we have a common color. Now the question is, what's the probability of a tail and 2 showing? A tail and 2. I only have 1. This is a tail and 2. How many of that? Okay, you only just have 1. Out of 1, 2, 3, 4, 5, 6. Out of 6 times 2, we have 12. So probability of a tail, a T1 showing, will be equal to just 1, T2 rather, 1 upon the whole space. So we have 1 upon 12. That gives us our answer. The last question before we go to other types of probability, other aspect of it. So we have when 2 fair coins are thrown, the probability of getting at least 1 head is, now these questions are actually cheap questions. but I take it as a fundamental, the beginning of probability, the theoretical approach. So we have two fair coins are thrown, probability of getting at least one head. If a fair coin is thrown, of course, I said before, a coin will always have an outcome of either head or tail. Either head, there are two, or tail. So what do we have now? We have this, we have this, we have this, we have this. So this one will be head, 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 tail, tail, head, then tail, tail. The question says, what is the probability of getting at least one head? At least one head means the least you can have is one head. The least you can have more than one head. We have a particular head here, have a particular head here, and of course we have head at least, so you can have more than one head. So the whole space is 4. So that probability is equal to 3/4. Thank you so much. See you some all the time.